Today we're going to be taking notes on solving and graphing inequalities. So we're going to jump down a little bit where it says rules for graphing on your notes paper. It says you can graph solutions to inequalities on a number line. But we need to make sure that we pay close attention to whether the circle is open or closed and which way the arrow faces. So up at the top here, we're going to use an open circle for less than or greater than signs. We're going to use a closed circle for less than or equal to or greater than or equal to signs. And the big difference there is if there's a line underneath the symbol. So when you see that line underneath, that means you need a closed circle. Let's move down to our first couple of examples. So our first example is x is less than 3. Remember, anytime that I have that word is with less than, that is a clue that we're going to be using the less than symbol. Now, this symbol does not have the line underneath, so I'm going to use an open circle at 3. And when I'm looking for the numbers that are less than 3, I'm going to look for the numbers that are smaller. So my arrow is going to go to the left to all those numbers that are smaller than 3. Look at our next example. X is greater than -1. So again, when we see that word is with greater than, that's a hint that we have that actual symbol, not just adding or subtracting. So I look for that number. I do not have a line underneath, so I'm going to use an open circle at -1. And then I'm going to look for all the numbers that are bigger than -1. In this case, all of those numbers that you see to the right, 0, 2, 4, 6, 8, those are all the bigger numbers than -1, so my arrow is going to point in that direction. Now, when we have to go backwards, the first thing that you want to notice is where that circle is. So this circle is at -2, and I always want to start out with my variable. Now this is an open circle, so I know that it's either less than or greater than, and I'm looking for where that arrow is pointing. I'm looking at all those numbers that are covered by the arrow. So -4, -6, -8, those are all numbers that are smaller than -2. So I'm going to use less than because I'm covering all of the smaller numbers. If you look at that end point of that arrow, you may even notice that the end of the arrow on the left is the same, it's pointing the exact same way as the less than symbol. So that is a way that we can use to help us remember which is which. So if the arrow is pointing to the left, then we are using less than. Let's look at our next example. This time our circle is at +4. So I'm going to write +4. I'm going to put my variable out front. Now this is a closed circle, so that means that I do need to have that extra line underneath. And now I'm looking and my arrow is pointing to the right. So that is greater than or equal to +4. Remember, if it's got a closed circle, it needs that extra line. So over on the left-hand side of your paper, it says that if we need to find a solution, we can always graph our inequality. If the arrow covers the number, it is a solution. So all of those inequalities that I've just graphed here, the big difference here is that inequalities have a lot of different solutions. When we solve an equation, there is one answer. I get x equals 3, for example. But for an inequality, and you can tell by this graph, all of those numbers that are covered by the arrow are solutions to that inequality. So let's look at that first example that we drew out. It says that we need to circle all the solutions to x is less than 3. So I'm looking at that top left one there. Remember, solutions make an inequality true. So let's look at that first one that they want me to think about, +5. Well, if I find where +5 is on that number line, So I'm going to use a highlighter circle to kind of show where I'm talking about here. So I just put a highlighter dot where positive 5 is on the number line. You can clearly see that that arrow is not covering up positive 5. So I'm going to cross out 5. It is not a solution to that inequality. Let's look at negative 12. I'm going to move my highlighter dot to find negative 12 on my number line. Well, negative 12 doesn't exactly fit on this number line, but I know that it's going to be past negative 8. Well, if I were to extend my number line and extend my graph, because it has that arrow, it can keep going on forever, it would cover up negative 12. So negative 12 is true in that inequality, so I'm going to circle it. Let's look at negative 3 now. If I move my highlighter circle to where negative 3 is on the number line, my arrow passes right over where that is. So that is a solution. I'm going to circle that as an answer. Now let's look at positive 2. Again, I'm going to move my circle, find where positive 2 is on that graph. So positive 2 is close to that circle, but it is on the right side. It's on the left-hand side of it, so it is a solution. So I'm going to circle that. Now, we don't always have to graph every single one. We can also solve this mathematically by substituting in the value where x is. So in this case, if I'm checking for 3, I'm going to rewrite that inequality with 3 where x was. So 3 is less than 3. Now, this is a tricky one because as I'm looking at that inequality, well, they're the same number, but look at my circle in my graph. It's an open circle. 3 is not less than 3. It is equal to 3. So that is not true. I cannot circle that as a solution. So I'm going to cross it out. Let's check 0 now. If I put 0 in where that variable was and write down the rest of it, less than 3, I'm going to go ahead and read that to myself and decide if it's true. 0 is less than 3. I know right away that having $0 is less money than having $3. So that is true. That is a solution. So I'm going to put a check mark next to that, just so I remember that that one was true. All right, let's try 15. If I substitute 15 in where x was, I would have 15 is less than 3. Right away, I know that that is incorrect. So I'm going to put an x and x out 15. That is not true. That is not a solution. Now let's try negative 8. Negative 8 is less than 3. Well, any negative number is going to be less than a positive number, so that one is true. So I can circle it as a solution. Now look, we had one inequality we were solving for, that x is less than 3. And look at how many solutions we just listed. So inequalities have many different solutions. There's more even than what we circled here. That's important to remember. Now let's talk about our actual rules for solving. We are going to solve inequalities exactly the same way as how we solve equations. Just like equations, if I see an inequality problem, I'm going to have railroad tracks, I'm going to have a box around the term with the variable, I'm going to keep it balanced so that I do the same operation on each side. All of those things are still true. The one thing that we have to watch out for is flipping the sign when you multiply or divide by a negative number. And I'm even going to highlight that because that was the most important thing on this sheet that we need to make sure that we remember is when we need to flip the sign. And remember, that's only for multiplying or dividing by negative numbers. So let's try out an example and we're going to check over that trick. Again, it's just like equations. I need railroad tracks. I need a box around my term with my variable. That means I'm getting rid of adding 2. Well, the inverse of addition is subtraction. So I'm going to subtract 2 from both sides. When I look at what's left, those 2's will cancel out, and I have x. On the right-hand side, I have negative 6. and I need to check if my sign is going to flip or not. Well, remember, it only flips if I multiply or divide by a negative. That did not happen, so it's going to stay less than. Let's check number 2. Railroad tracks. Look for that variable. In this case, I only have one number that I'm getting rid of, so I'm going to get rid of that -2. They are squished together, so that means multiplying. I'm going to divide to get rid of them. Both sides. On the left-hand side, those -2's will cancel out. I'll just have x. On the right-hand side, -6 divided by -2 equals +3. And now I'm checking for that rule. I flip the sign if I multiply or divide by a negative number. Well, look at what I wrote in green here. I divided by -2. That's a negative number. So I'm going to flip my sign backwards. Instead of less than or equal to, I'm going to use greater than or equal to. I still need that line underneath. It's just facing the other direction. Let's look at example 3. I'm going to put railroad tracks. I'm going to put a box around 2x. And I'm going to get rid of adding -3. Well, if I need to get rid of negatives, I'm going to use positives. So I'm going to add 3 to both sides. And now I'm going to see what cancels out. Well, the -3 and the +3 will go away. I'll just have 2x. On the other side, I'll have -30. Now I've got to get rid of that 2. So I'm going to divide by 2 on both sides. The 2's will cancel out. I will just have x on the left. On the right-hand side, I'll have -15. And now I'm checking if I need to flip the sign. Well, I did divide in this problem, but I divided by a +2. Since it was a positive number, I do not need to flip it. It's going to stay greater than. Let's look at number 4. I'm going to draw railroad tracks, put a box around x over -4. I'm going to add 7 to both sides, bring down what's left. So I have x over -4. I have not multiplied or divided by any negatives, so it's staying less than, and 3 + 7 is 10. Well, if I need to get rid of dividing by -4, I'm going to do the opposite and multiply by -4 on both sides. On the left-hand side, those -4's will cancel. I'll just have x. On the right-hand side, I'll have -40. And when I multiplied by a negative number, so I do need to flip that sign. So instead of less than, I'm going to use greater than. Let's look at number 5. I'm going to draw railroad tracks, put a box around -2x. And now I'm going to get rid of adding 4 by subtracting 4. Bring down what's left. I have -2x. Don't need to flip it yet, so it's going to be -2x is less than 4. Now that -2 and the x are squished together, that means multiplying. So I'm going to divide by -2 on both sides. I'm going to get x and -2. And when I divided, that was by a negative, so I'm going to flip it to greater than. This is a flipping problem. Last example here. Draw your railroad tracks, put a box around that term with the variable. You need to get rid of that other number, so I'm going to add 5 to both sides. Bring down what's left. I have x over 3 equals 13. Sorry, not equals. This is an inequality, so I'm going to keep the greater than greater than 13. All right. Now I'm going to get rid of that 3 that I was dividing, so I'm going to use the inverse and multiply. Same thing on the other side. Those 3's will cancel out. I will have x. On the right-hand side, I'll have 39. And when I multiplied, that was by a positive number, so I do not need to flip my sign. It's still going to be greater than. So the number one thing up at that top of my screen right here, remember, inequalities, flip the sign if you are multiplying or dividing by a negative number. Make sure you have all of the examples of every single thing I've written.